So the big missing piece that we skipped over in the last module was around the permissions I need as an AWS user to be able to use the serverless framework to deploy my Lambda functions. As I noted in the annotations, it uses the Node.js AWS SDK to call AWS APIs such as S3 to upload the deployment package and to CloudFormation to trigger the actual deployment process itself. You saw how I didn't have to do anything special in the demo. This is because my default AWS profile was configured with an IAM user with full admin access. And this is the quickest way to get started with the serverless framework. But if you were to measure this approach on the axis of security versus convenience, it's going to land somewhere here as it optimizes towards convenience but not secure at all. You really wouldn't want to be handing out admin access to your developers for the production environment. Any leaked credentials would give attackers full access to your AWS environment. On the other end of the spectrum, you can also apply the principle of least privilege and start with the bare minimum of permissions such as S3 create bucket and gradually add more permissions as the developers bump against the wall when they try to deploy. The problem with this approach is that the range of possible permissions that you need are very diverse. First, you need permissions for the things that the serverless framework will actually need when you deploy or when you remove an existing deployment. This includes creating and deleting S3 buckets and creating CloudFormation stacks, etc. But as you'll see later, you can also declare additional resources such as DynamoDB tables and SNS topics in your serverless.yaml, and those will need to be included as part of the CloudFormation stack. In some cases, the serverless framework will also create those for you automatically when you configure your function's event source. For example, when you configure a function's event source to be an SNS topic or a CloudWatch event. And then you have plugins. One of the strengths of the serverless framework is its extensibility, and there are many useful plugins out there that fill the gap in what the framework provides out of the box, such as creating step function definitions. But it also means that they introduce more permissions that need to be added to your IAM user. And finally, you also have to worry about rollbacks. If a deployment fails for whatever reason, then CloudFormation will also need to roll back any changes that it made during the deployment, deleting DynamoDB tables or APIs, etc. And so the IAM role will also need permissions to delete any resources that is permissioned to create in the first place. So you can imagine that's an awful lot of walls the developers need to bump their heads against to arrive at a set of permissions they actually need, which is why it's a very secure approach, but also very painful to execute as well. There are some help out there in the form of this Yeoman generator, which spits out a policy JSON file that you can use to create the IAM policy. It's a good starting point, but it's far from complete, and only includes the common permissions that the serverless framework itself needs, which, as we discussed, is only part of the problem, which is why, even with the help of the policy generator, it will still be a rather slow approach to adopt. Nonetheless, this is the approach that a lot of companies have adopted, especially those large enterprises who tend to be much more prudent when it comes to security. Finally, instead of starting small and gradually expand the set of permissions, you can also go the other way around. By starting with a dedicated deployer user with admin access in your development account, developers can freely develop and experiment to their heart's content, but then you only copy over the permissions they have actually used to the deployer role in the production account. This way you introduce less friction in the process, but is predicated on the assumption that you have account level separation between environments, so that those admin access are never handed out for the production account. You can see what services were accessed by, and I'll stress this, the dedicated deployer user or users, so that permissions needed by the deployment process are not conflated with other things the developers would do on their personal account, like using the AWS console or CLI tools, or to run the application code against Amazon services. At this point, you can either give full permissions to those services, or you can delve further into what actions are performed against those services by checking the events history in CloudTrail, and then only permission for those actions and the reverse actions that will be needed for rollback. So this approach is a bit more convenient, but also less secure, as you're more likely to over-provision. But I personally find it a good compromise, and for the startup environments that I work in, it actually works pretty well. Okay, so in the next module, we're going to start working on our demo app for real, and we'll start by creating the landing page for our e-commerce site.